Hey everybody, welcome to Bill Sky, the Assembly Guy, and in today's video we're going to talk about conditional jumps. We're going to talk about if statements in assembly language, which there aren't any, but we're going to talk about how to actually do an if statement in assembly language. Now this is for Intel x86-64, so let's jump right into it. So I have a 32-bit assembly language project opened up, and let's talk about how you simply move around in your program. So let's say if I have some code here. I mean, it can be anything. And let's say I want to move from this line of code to that line of code, avoiding that line of code. Now I know it's stupid, but there's a simple command called jump. And jump moves to a label. It jumps to a label, so it jumps around something. So if I put that label right there, and that label is label1 colon, what's going to happen is this program is going to begin, the move 0 to EAX is going to be executed, then it's going to jump to label 1. Label 1 is going to be gotten to, and then we're going to do that line of code. This is actually code right here, which is unreachable. Now, the interesting thing about the assembler, a compiler would tell you about that, but the assembler pretty much tells you nothing. Now, oh, I forgot the L. So the assembler tells you nothing. It doesn't tell you that it's unreachable code. It doesn't tell you you're a moron. I mean, it just doesn't tell you anything. But that's the simplest way of moving around in a program, and if you are a C++, C, or COBOL coder, Fortran coder, it's a lot like the go-to statement, where it says go to a specific label in the program. So that's jump, and that's basically what it is, just a go-to. Now we can ask other questions. Let's get rid of that code. I'm going to move, let's say we move 10 into EAX, we move into EBX. Let's say we move, let's put something big into EAX. I'm going to put 0, 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to fill up EAX with all of that data. And I believe that's 32 bytes. And then if I say add EAX comma 1, you know that all of those filled up bytes, so EAX is all ones. If I add 1 to it, what's going to happen? It's going to carry. So the addition of that 1 to EAX is going to carry, so I can say jump if carry to some label. And some label might be down here. And then if it doesn't carry, maybe we want to push it, and then we want to call print 32-bit num hex. Now this isn't a project. This isn't a project that is connected to my function, so this actually will not compile, or this will not assemble this one line here, but that's what you can do. So if the carry flag was found to be an issue, if it was raised, then you can jump to that. Another way you could do it is jump if not carry. So you could do something like push error message, and then instead of calling print 32-bit num message or num hex, you could say call print string, and then call print and L. And then some label will be jumped to if there was not a carry. In other words, if this addition was okay, let's go ahead and take away an F. That addition would be okay, where we add 1 to EAX, it will not carry, so this line of code will be executed and we'll jump to there. Now normally below every label I always like to put a no-op just so the debugger will stop there. And as I said, this will not assemble because this is not a functions project, but let's go ahead and comment those out and we can debug this. And I don't really have exit message, so let's go ahead and just put a no-op there. I'm going to make it. It made okay. Now let's go ahead and bring up a terminal. And we're going to jump down to our first no-op, and let's actually see this happen. So we're going to do that. We're going to move all F's other than one nibble. So the most significant nibble is going to be all zeros. So EAX, adding 1 to EAX is not going to cause a carry. Jump if not carry to some label. There we are, we're at the line after some label. So some label, a label doesn't take up memory, but it does label the next line of code. So that's another conditional jump if not carry. If you're dealing with signed numbers, like let's say if we say -1 and we add 1, instead of not carry, we want to say not overflow. So remember, signed is not overflow or overflow. Unsigned is carry or not carry. So you can do that. What if you put a -1 there and then you add 1? What if we want to see if the result is a 0? I could say jump at 0 to some label. So if the 0 flag is set, that means that the result of an arithmetic operation resulted in 0. It's going to jump to some label. Let's go ahead and make that, and let's try her out. Step over, we put -1 in EAX, we add 1 to EAX, jump if 0, and it jumped to some label because that add of 1 resulted in a 0, so it turned on the 0 flag. All right, great. Let's look at some other ones. There's also one jump if not 0. So if the result was not 0, jump to some label. In this case, it will be 0, so it will not jump to some label. It will do this no op. And that's what I just love, no ops. Okay, so we talked about signed. So now let's talk about an actual if statement. What we've done right here is we've just been checking the status flags of the CPU, but let's actually do something that has to do with an if statement. So I'm going to put some comments in here, and let's say I'm going to say if EAX is less than 10, I want to increment EAX. Oh, what's wrong with my fingers today? Else, and I got to close that off. I know this isn't a real program, but I like to be syntactically correct. Else decrement EAX. So there's a little C or C++ code there, and of course C and C++ you don't access the registers directly. I mean, you can, but you know it's normally not done because you would have to do it with inline assembly. But with that said, so that's the if statement that we want to create. How would we do that? Well, let's go ahead and put some data in there. So I'm going to move into EAX 5, and then what I'm going to do is so EAX now has a value. Now I want to compare EAX with the number 10. So I can't say if, I have to say compare EAX with the number 10. And what that does is that sets the flags in the flag register, and then we can query them. So a number of things, I can say jump if equal to, I don't know, EAX equal to 10. I can say jump if not equal, EAX not equal to 10. I can say jump if, now this is unsigned, so let's assume this is unsigned. So if it's unsigned, we're going to say jump if below to EAX less than 10. Jump if above JA to EAX greater than 10. What if it's less than or equal to? I say jump if below or equal to EAX less than equal 10. Jump if above or equal EAX greater than equal 10. So those are a number of them. So we check to see if it was equal to, if it was not equal to, if it was less than, which is jump below, if it's above, greater than, jump above, jump if below or equal to, less than or equal to, or jump if above or equal to, or greater than or equal to. So I normally like to put little comments here. I'll say that's equal, that's not equal, this one right here, less than, this one right here, greater than, this one right here, less than equal to, and this one right here, greater than or equal to. Now that's unsigned. Well, what about signed? So let's go ahead and do this with signed. So I'm going to move into EAX, -5. Now, if you're dealing with signed numbers, if you're dealing with numbers where the most significant bit is going to establish whether or not it's signed or not, you're going to be using that as the signed bit. You do not want to use that as a value bit. And also, the signed numbers, the negative numbers, are going to be 2's complement. So you can't mix apples and oranges. You can't compare the number -5 and the number +5 in unsigned nomenclature, because -5 will always be greater than +5 unsigned. However, signed, -5 will never be greater than +5. So you have to make sure you use the unsigned or the signed comparators. So we're going to compare it with 10. Now I'm going to just copy these and we're going to change them. So equal is still the same. It'll still be jump if equal, jump if not equal. However, less than will be L, jump if less than. Greater than will be G. Less than or equal to will be LE. Greater than or equal to will be GE. So pretty simple. So the thing to remember is with signed, you're dealing with above and below. That's how I remember it. Unsigned. With signed, you're dealing with greater, G, and less than, L. That's how I remember these things. And this is pretty much it. And you will branch to these different labels. Now I haven't defined any of these labels, and I'm going to go ahead and do that. I'm just going to define the labels down here. And the way I'm going to do that is I'm just going to, I just want to make sure that this assembles, that I didn't type something in completely wrong. And I'm just going to put a colon. At the end of each one, and then I'll do a no-op. Whoops. After each one. And that's what no-ops are great about. I can just put those there and we can see. And we'll go ahead and test one. All right, great. So let's go ahead and build this. Let's debug it. Let's run it. There we are at our no-op. Okay, so I'm going to move 5 to EAX, and then I'm going to compare it with 10, and this is for unsigned. So EAX will be less than 10. They're not equal to, so I'm going to step over. Are they equal? Nope. Are they not equal? They certainly are, and they jump to that not equal. So we have to change our code a little bit. So what I'm going to do here is I'm going to comment out the jump if not equal to, rebuild it, run it, and let's walk through it again. Okay, we're going to compare EAX with 10. EAX contains a 5. Jump if equal, nope. Jump if below. So is EAX below 10? Certainly is, so it jumps to EAX less than 10. Really cool stuff here. Now, I would like to demonstrate to you how -5 can be greater than 10 if you don't do the right thing. So I'm going to do that here. So I'm going to move into EAX 10. I'm going to compare EAX with -5. Jump if above. Now I'm using the unsigned jump. A is for unsigned. Jump if above. So this is going to say, is EAX greater than -5? And actually, let's put -5 in there. Let's put 10 there, +10. So I'm going to put -5 into EAX. I'm going to compare EAX, which is -5 to 10. It should jump, because jump above, I'm not using signed, I'm using unsigned. I'm going to say jump if above to unsigned mess. And then we'll test it out later. So here's unsigned mess. No op. And this is an example of how using the wrong jump, or no, how confusing signed and unsigned can screw things up. Let's go ahead and save and build this. Notice the assembler says nothing to you. And this works exactly the same way in Windows. So let's go ahead and debug it. All right, so we're going to run it. Step over. Let's take a look at the registers. I'm going to put a -5. You can see it right there, a -5 into EAX. I'm going to compare it with 10. And I'm not going to use the jump G, which is used for signed. I'm going to use jump above, which is used for unsigned. And boom, unsigned mess. So basically it's saying that -5 is greater than 10. And why am I saying that? Because it compares the left to the right. If the left is greater than the right, then it will jump. And this is because I use JA and not JG. So I'm going to end this. I'm going to change this to a JG, which is for signed. I'm going to put a no op right below that just so we can stop there. I'm going to build it. I'm going to run it. Okay, we put -5 into EAX. We compare it with +10. Jump if greater. Now is -5, EAX greater than 10? Nope. So it goes to the no op. So that's why it's so important, because the above and below are for are for non-two's complements numbers, but the L and the G, less than, greater than, those are for signed two's complement numbers. And with that said, that is the simple mechanism for comparing two values. You always do it in a register. You never really do it in memory. You can dereference memory, but I really suggest you put things into registers. And what we're going to do in the next video is that we're going to take actual if statements that might be found in a C or C++ program, probably also in a Java program, and we're going to show you how to implement those in assembler language using this conditional branching. See you then.